Unshielded control cables are not suitable for use in hospital security, lighting, elevator, and heating, ventilation, and air conditioning systems. This is due to several key factors. Firstly, electromagnetic interference, or EMI, is a major concern. Hospitals contain a high concentration of electronic devices that emit electromagnetic interference. This interference can disrupt the signals in unshielded control cables, leading to errors or malfunctions in critical systems like security, lighting, elevators, and heating, ventilation, and air conditioning. Secondly, the sensitive nature of medical equipment demands shielded cables. Medical devices in hospitals are highly sensitive to electromagnetic interference. Unshielded cables can introduce unwanted noise and distortions, potentially affecting patient safety and the proper operation of medical equipment. Thirdly, safety regulations play a crucial role. Hospital environments are governed by strict safety regulations, including those related to electrical safety and electromagnetic interference control. The use of unshielded cables can violate these regulations, posing risks to both patients and staff. Fourthly, long-term reliability is a factor. Unshielded cables are more susceptible to degradation and damage from electromagnetic interference over extended periods. This can lead to potential system failures and increased maintenance requirements. Now let's consider the benefits of using shielded control cables. Firstly, shielded cables offer excellent electromagnetic interference protection. They act as a barrier against electromagnetic interference, reducing interference and ensuring reliable signal transmission. Secondly, they improve signal integrity. Shielding prevents noise and distortions from affecting the quality of signals transmitted through the cables. Thirdly, shielded cables ensure compliance with regulations. They meet the stringent safety and electromagnetic interference control requirements for hospital environments, ensuring adherence to industry standards. Fourthly, shielded cables offer long-term durability. Shielded cables are more resistant to electromagnetic interference-induced degradation, leading to increased system reliability and reduced maintenance costs. To summarize, using shielded control cables in hospital security, lighting, elevator, and heating, ventilation, and air conditioning systems is essential to ensure reliable operation, patient safety, and compliance with regulatory requirements. Understanding the role of electromagnetic interference, the sensitivity of medical equipment, and the importance of safety regulations is crucial in making informed decisions about cable selection in hospital environments. The principles behind shielding effectiveness involve understanding how different materials interact with electromagnetic fields and how cable design can minimize interference. Shielded cables typically incorporate a conductive layer, often made of copper or aluminum, that surrounds the inner conductors. This shield acts as a Faraday cage, intercepting electromagnetic radiation and diverting it to ground. The effectiveness of the shielding depends on several factors, including the material's conductivity, the shield's thickness, and the frequency of the interfering signal. Different types of shields are available, each offering varying levels of protection. Braided shields, foil shields, and combination shields are common options, each with its own advantages and disadvantages in terms of cost, flexibility, and shielding effectiveness. The choice of shield depends on the specific application and the level of electromagnetic interference expected. Proper grounding is also essential for effective shielding. The shield must be properly grounded to provide a path for the intercepted electromagnetic interference to dissipate. Without proper grounding, the shield can become a source of radiation itself, negating its intended purpose. Grounding techniques include using low impedance connections to the ground plane and ensuring that the ground path is as short as possible. Cable installation practices also play a significant role in maintaining shielding effectiveness. Cables should be routed away from sources of electromagnetic interference such as power lines and high-frequency equipment. Sharp bends and kinks in the cable can compromise the shield's integrity, reducing its effectiveness. The use of appropriate connectors and termination techniques is also crucial to ensure a continuous shield from the cable to the equipment. Testing and verification are essential to confirm that the shielding is performing as intended. Shielding effectiveness can be measured using various testing methods, such as transfer impedance measurements and radiated emissions testing. These tests can identify weaknesses in the shielding and verify that the cable meets the required performance standards. Now let's discuss specific applications within a hospital setting where shielded cables are particularly critical. In security systems, shielded cables are essential to protect sensitive data and prevent unauthorized access. Security cameras, access control systems, and alarm systems all rely on reliable communication links that are free from interference. In lighting systems, shielded cables can prevent flickering and dimming caused by electromagnetic interference, ensuring consistent and reliable illumination. This is particularly important in operating rooms and other critical care areas where precise lighting is essential. In elevator systems, shielded cables are crucial for ensuring the safe and reliable operation of the elevator. Electromagnetic interference can disrupt the elevator's control system, leading to malfunctions and potential safety hazards. In heating, ventilation, and air conditioning systems, shielded cables can prevent interference with the control system, ensuring efficient and reliable operation. This is important for maintaining a comfortable and healthy environment for patients and staff. Furthermore, consider the regulatory landscape that governs the use of cables in hospital environment. Various standards and regulations, such as those established by the National Electrical Code, or NEC, and other organizations, specify requirements for cable construction, installation, and performance. These regulations are designed to ensure electrical safety and minimize the risk of electromagnetic interference. Compliance with these regulations is essential for hospitals to maintain their accreditation and avoid potential liability. Ongoing maintenance and inspection are also critical for ensuring the long-term effectiveness of shielded cables. Cables should be regularly inspected for signs of damage or degradation, and any issue should be addressed promptly. This includes checking for loose connections, damaged shielding, and other potential problems. Proper documentation and record keeping are also important for tracking cable performance and identifying potential issues before they lead to system failures. When selecting shielded cables for hospital applications, it's important to consider several factors, including the type of equipment being connected, the level of electromagnetic interference expected, and the applicable regulations. Consulting with qualified electrical engineers and cable manufacturers can help ensure that the appropriate cables are selected for each application. Furthermore, it's important to stay informed about the latest advancements in cable technology and shielding techniques. Cable manufacturers are constantly developing new and improved products that offer better performance and durability. Staying up to date on these advancements can help hospitals make informed decisions about cable selection and maintenance. Shielded cables play a crucial role in ensuring the reliable and safe operation of critical systems in hospital environments. By understanding the principles behind shielding effectiveness, the importance of proper grounding and installation, and the applicable regulations, hospitals can minimize the risk of electromagnetic interference and maintain a high level of performance. This knowledge is essential for electrical engineers, facility managers, and other professionals responsible for maintaining the electrical infrastructure in hospitals. Understanding electromagnetic compatibility, (ENC), is another important aspect of cable selection and installation in hospital environments. Electromagnetic compatibility refers to the ability of electronic equipment to function properly in its intended environment without causing or experiencing interference. Achieving electromagnetic compatibility requires careful consideration of all potential sources of electromagnetic interference and the susceptibility of electronic equipment to that interference. Cable shielding is just one component of an overall electromagnetic compatibility strategy. Other measures, such as filtering, grounding, and equipment placement, may also be necessary to achieve electromagnetic compatibility. In hospital environments, electromagnetic compatibility is particularly important due to the high density of electronic equipment and the sensitivity of medical devices. Electromagnetic interference can disrupt the operation of medical equipment, leading to inaccurate readings, malfunctions, and potential safety hazards. Therefore, it's essential to take a holistic approach to electromagnetic compatibility, considering all potential sources of interference and implementing appropriate mitigation measures. When evaluating the electromagnetic compatibility of a system, it's important to consider the frequency range of the interfering signals. Different types of shields are effective at different frequencies. For example, foil shields are generally more effective at high frequencies, while braided shields are more effective at low frequencies. The choice of shield should be based on the frequency range of the expected interference. It's also important to consider the impedance of the cable and the equipment it's connected to. Impedance mismatches can cause reflections and standing waves, which can increase electromagnetic interference. Proper impedance matching is essential for minimizing interference and ensuring reliable signal transmission. The use of twisted pair cables can also help reduce electromagnetic interference. Twisted pair cables have two conductors that are twisted together, which helps to cancel out electromagnetic interference. Shielded twisted pair cables offer the best of both worlds, providing both shielding and twisted pair benefits. In addition to cable selection and installation, proper grounding is essential for achieving electromagnetic compatibility. Grounding provides a low impedance path for electromagnetic interference to dissipate, preventing it from affecting sensitive equipment. A single-point grounding system is often recommended for hospital environments to minimize ground loops and ensure that all equipment is properly grounded. Regular testing and maintenance are also important for maintaining electromagnetic compatibility. Testing can identify potential problems, such as loose connections or damaged shielding, before they lead to system failures. Maintenance should include regular inspections of cables, connectors, and grounding systems. Furthermore, it's important to train staff on the importance of electromagnetic compatibility and proper cable handling techniques. Staff should be aware of the potential sources of electromagnetic interference and the measures that can be taken to minimize it. Proper cable handling techniques, such as avoiding sharp bends and kinks, can help maintain shielding effectiveness and prevent damage to cables. In conclusion, shielded cables are a critical component of an overall electromagnetic compatibility strategy in hospital environments. By understanding the principles of electromagnetic compatibility, selecting appropriate cables, and implementing proper grounding and installation techniques, hospitals can minimize the risk of electromagnetic interference and ensure the reliable and safe operation of critical systems. This requires a collaborative effort involving electrical engineers, facility managers, and other professionals responsible for maintaining the electrical infrastructure in hospitals. Remember that specific requirements will vary based on the local electrical codes and regulations. Always consult with a qualified professional to ensure compliance. Consider the advantages of using fiber optic cables in certain hospital applications. While shielded copper cables are often the standard for many control and data transmission needs, fiber optic cables offer inherent immunity to electromagnetic interference. This is because fiber optic cables transmit data using light rather than electrical signals. In areas with extremely high levels of electromagnetic interference, such as near MRI machines or other powerful medical equipment, fiber optic cables can provide a more reliable and secure communication link. Fiber optic cables also offer higher bandwidth capabilities compared to copper cables, allowing for faster data transmission rates. This can be beneficial for applications that require high-speed data transfer, such as video surveillance systems or large data storage networks. However, fiber optic cables also have some drawbacks. They are generally more expensive than copper cables, and they require specialized equipment for installation and termination. Fiber optic cables are also more fragile than copper cables and are more susceptible to damage from bending or crushing. The decision to use fiber optic cables versus shielded copper cables should be based on a careful evaluation of the specific application requirements, the level of electromagnetic interference expected, and the budget constraints. In some cases, a combination of both types of cables may be the best solution. Also, be aware of the potential for galvanic corrosion when using different types of metal cables and connectors. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. This can lead to corrosion of one of the metals, which can compromise the integrity of the connection and reduce the effectiveness of the shielding. To prevent galvanic corrosion, it's important to use compatible metals for cables, connectors, and grounding systems. If dissimilar metals must be used, a dielectric barrier can be used to prevent direct contact. The National Electrical Code, or NEC, provides guidance on selecting compatible metals and preventing galvanic corrosion. Always follow the NEC guidelines when installing electrical systems in hospital environments. Finally, remember that cable management is an important aspect of maintaining the reliability and safety of electrical systems in hospitals. Cables should be properly organized and supported to prevent strain and damage. Cable trays, conduits, and other cable management systems can help keep cables organized and protected. Cables should also be labeled clearly to facilitate identification and troubleshooting. Regular inspections of cable management systems should be conducted to ensure that cables are properly supported and protected. Any damaged or deteriorated cable management component should be replaced promptly. By following these best practices for cable management, hospitals can minimize the risk of cable damage, improve system reliability, and ensure the safety of patients and staff. Considering the increasing use of wireless technology in hospitals, it's also important to address the potential for interference between wireless devices and wired systems. Wireless devices emit electromagnetic radiation that can interfere with wired systems, and vice versa. To minimize interference, it's important to carefully plan the placement of wireless access points and other wireless devices. Wireless access points should be located away from sensitive medical equipment and shielded cables. The use of directional antennas can also help focus the wireless signal and reduce interference. Furthermore, it's important to use appropriate wireless security protocols to prevent unauthorized access to the network. Unauthorized access can lead to malicious attacks that can disrupt the operation of critical systems. Regular security audits should be conducted to identify and address any vulnerabilities in the wireless network. It's also important to educate staff on the importance of wireless security and proper device usage. Staff should be trained on how to connect to the wireless network securely and how to avoid downloading malicious software. By taking these measures, hospitals can minimize the risk of interference between wireless devices and wired systems and ensure the security and reliability of their networks. Also, remember to document all cable installations and modifications. Accurate documentation is essential for troubleshooting, maintenance, and future upgrades. Documentation should include cable types, lengths, routing paths, and termination points. As-built drawings should be created to show the exact location of all cables and equipment. Documentation should be updated whenever any changes are made to the electrical system. This will ensure that accurate records are available for future reference. Electronic documentation systems can be used to store and manage cable documentation. These systems can provide easy access to information and facilitate collaboration among different departments. Regular backups of electronic documentation should be made to prevent data loss. By maintaining accurate and up-to-date documentation, hospitals can improve the efficiency of their electrical system management and reduce the risk of errors. Consider the impact of future technologies on cable requirements in hospitals. As technology continues to evolve, new and more demanding applications will emerge. These applications may require high bandwidth, low latency, or greater immunity to electromagnetic interference. It's important to anticipate these future needs when planning cable installations. The use of future-proof cabling systems can help ensure that the electrical infrastructure can support future technologies. Future-proof cabling systems typically include high-performance cables, connectors, and cable management systems. These systems are designed to meet the demands of current and future applications. Regular assessments of cable requirement should be conducted to identify potential future needs. These assessments should take into account the latest technological advancements and the hospital's long-term strategic goals. By planning for the future, hospitals can avoid costly and disruptive upgrades down the road.